When you are sourcing forged components for oil and gas, defense, aerospace, nuclear, railways, or energy, one decision can affect the entire performance of your component. Should it be made by closed die forging or open die forging? Both processes create strong, reliable forged parts, but they are not used for the same purpose. The right process depends on geometry, volume, strength requirements, tolerance, lead time, and compliance. Closed die forging shapes heated metal inside a die cavity that matches the required part geometry. This makes it ideal for repeatable shapes, tighter tolerances, near-net components, and controlled grain flow around critical features. That is why buyers often choose closed die forging for complex flanges, yokes, brackets, couplers, connectors, and parts that need consistent geometry across a batch. Open die forging is different. In this process, metal is shaped between flat or simple dies without being fully enclosed. It offers greater flexibility and is often used for large parts, low volume requirements, one-off components, and heavy section forgings. Typical open die forged parts include shafts, stepped shafts, thick blocks, discs, rings, hollow cylinders, and heavy forged preforms that will later be machined. So how do buyers decide? First, they look at geometry. If the component has complex features and repeatable contours, closed die forging is usually preferred. If the component is large, simple, and heavy, open die forging may be the better route. Second, they look at volume. For repeat demand, closed die tooling can make economic sense. For low volume or changing designs, open die forging can avoid unnecessary tooling cost. Third, they look at strength. Closed die forging supports grain flow around the shape of the part, while open die forging allows deeper reductions through thick sections for internal soundness. Lead time also matters. If tooling already exists, closed die forging can be fast. But if new dies must be created, open die forging may be faster for first articles. Cost is also different. Closed die forging has higher upfront tooling costs but can reduce machining and scrap. Open die forging has lower upfront tooling cost but may require more machining later. So which one is stronger? The answer is both can be excellent. The right choice is not about which process sounds better. It is about which process fits the component, the application, and the risk involved.